So grades are due next Friday. It's the end of the 9 weeks. Oh, this is what I remember I was going to say. Everything we do next week is going to push forward into the second 9 weeks. Okay. So there's kind of be like a kind of like a lap, what do you call it? Overlapping week where I'm going to be getting you caught up to pass from the first 9 weeks, but all those grades are going to be going towards the second 9 weeks. So everything we do is a grade at some point, but when you get your grade sheet tomorrow, that's kind of the least it could be for the first 9 weeks. So obviously the point is get it up if you need to. Now this warm up, these are vertical angles, it says, and we should know that because we did notes on this the first week of school. Okay, everyone with me? No phones. Okay, what do we know about vertical angles? Say what? Okay, they don't make 90. They're across from each other. The question are, I guess I'll give you options. Are they congruent or are they supplementary? Are they not supplementary? Okay, so if they're across from each other like this, you call them vertical angles and they're the same. Okay, you can kind of look at them and see they're both acute. So again, vertical angles are congruent. So these measurements are going to be equal. Okay, so again, across from each other, you want to set them equal. We should not have headphones in our ears, please. Just don't do it. All right, so let's set it up. 2x plus 12 equals 4x minus 6. That's given. We'll do this as an algebraic proof. Now, first step, if x is on both sides, do I get rid of one or do I combine them? What do y'all think? Okay, you do get rid of one. X cannot be on both sides. It needs to be on one side. So I'm going to get rid of the smaller x. Which x is smaller? 2. So what do I do to get rid of that positive term? Subtract. So minus 2x on this side, minus 2x on this side. I'm going to bring down 12, and then 4 minus 2 is 2, x minus 6. Now, what's my reason? What did I just do? Subtraction, so it's the subtraction property. Okay, and then next step, x is on the right. What number do I need to get rid of on the right side? X is on the right. What number do I need to get rid of on the right? The loner, the minus 6. How do I get rid of a minus 6? The opposite is to add 6. Minus add, right? So plus 6, 6. 12 plus 6 is 18. And bring down 2x. Now, what did I just do? What am I going to put on my reason? A good addition property. Uh, 2 is in front of x. It's a coefficient that's being multiplied. What's the opposite? Divide by 2. Very good. Oh my gosh. There we go. Wait. Okay, yeah. So 9 equals x, and that is, I heard someone say division property. Are we done? X is by itself, but if you notice from our last 2 days, we want x on the left. We need to do a switcheroo. Flip it. X equals 9, but what's the reason? Look at you. That's awesome. Symmetrical property. Let me try that again. Symmetrical property. Okay. And that's good for our warm-up. Now, y'all got notes for the proofs on the way in? So let's go ahead and take a look at that. All right, here we go. Given. Okay, so is everyone looking up here? This is new. This looks kind of like the last 2 days, but I'm gonna tell you the beginning of these proofs are a little bit different, so you definitely want to pay attention. So everyone with me? If you have a phone in your hand, you got to put it down, please. Okay, number one, given angle LEG and angle TEN are vertical angles. Okay, that's given, and we're also given the measurements. Little m means measurement, which means the numbers, right? The measurement of angle leg is 10x minus 10. The measure of angle 10 is 8x minus 2. Okay, so we're given all three of those things, and we're trying to prove x is 4. This is called a geometric proof because now we're talking about shapes, like angles. Okay, now I'm going to draw a little picture off to the side. Vertical angles is like what we did on the warm-up. Hold on. LEG, L to E to G, looks like this. That's on one side. And then the other side, TEN, can look like that. Reminds me of my warm-up. So if you don't have a picture, you can draw a picture if it helps you see it, okay? But let's remember the last 2 days. Usually, what am I writing on the very first step? The reason's given, but the statement is whatever the top thing is. So same thing. This top thing is going to be your first statement. So let's go ahead and just rewrite that. Angle LEG and angle TEN are vertical angles. Okay. All right, those two angles are vertical. My reason for number one is always what? Given. Okay. First step should be easy. You just rewrite it. You put given. Then you got to start thinking a little bit. Okay. So let's think about it. If angles are vertical, that's why we want to be careful about when we do these steps. Okay? So, first step, vertical angles I know are congruent. So let's go ahead and write that. Angle LEG, rewrite that. Angle LEG is congruent to angle TEN. Okay, do you see how the first one leads to the second one? If they're vertical, then they're congruent. And y'all seen that congruent sign? It looks like equals with a little squiggle on top, little tilde, whatever. Now here's where something, this might be new to you. Why did I write that statement? Because that's the definition of a vertical angle. That was week one. We did definitions. Vertical angles are congruent. So I'm going to put, for my reason, definition of vertical angles. All right. Angle LEG is congruent to angle TEN. Now, I'm going to say this. I'm going to stress this, okay? Remind me, what's the definition of congruent? Congruent means same, what? It's been a little while. Okay, is everyone looking up here? Congruent means same size and same shape. Have y'all heard that before? Same size, same shape. Now notice, that has nothing to do with numbers or equals. It's just talking about when you look at it, it's the exact same, okay? So congruent has to do with angles, triangles, shapes of all sizes, not numbers, cool? But it also means if you measure it, it's going to be the same or equal. Okay, so here's the deal. Whenever you have a congruent statement, your next statement can be an equal statement. Okay, so congruent comes first, then equals comes next. Here we go. The only difference is that you have to put a little m in front of the angle because you're telling me the measurement, the number value, is equal. Here's what we're going to write. Measurement of angle LEG equals the measurement of angle TEN. So the definition of vertical angles was last step. So here's the deal. I went from congruent to equals. That's the definition of congruent. Let's go and write definition of congruent. All right. Now, we're going to replace those measurements with the values. Here we go. So on the left side, the measure of angle LEG is 10x minus 10. And the measure of angle TEN is 8x minus 2. Why? Substitution. By the way, you want to write small because I hate to say, I should have said this earlier, my bad, but we kind of run out of room here, unfortunately. So substitution. On this whole front side of the page, you want to write small. I'll just be honest. All right, so so far we started with vertical angles. We said they're congruent, so they're equal, so we plugged it in. That is how you start a geometric proof. You start with the shape, you get to the numbers, X is on both sides. X cannot be on both sides. Get rid of one. The smaller x, which is what? 8x has got to go. So it's positive. What am I going to do? Negative. Write small, please. Minus 8x. Minus 8x. 10 minus 8 is 2x. Minus 10 equals negative 2. By the way, do y'all see that? What do I bring down on the right side? Is it just a 2 or is there a sign? Negative 2. Be careful. If you see a minus sign in front, take it with it. It's a negative 2. What did I just do on both sides? What's my reasoning here? Subtraction property. Very good. Okay, now x is on the left. I need to get rid of the 2 or the minus 10. Which one's got to go first? Okay, good. The minus 10 because it's the loner. What's the opposite? Plus 10. Write small, please. So 2x equals negative 2 plus 10 is 8. And since I just added on both sides, I'm going to put the addition property. Everyone with me? Addition property. Last step, to get rid of that 2 in front of x. It's a coefficient that's being multiplied. What am I going to do? Divide by 2, divide by 2. Not negative because it's a positive 8, right? Right. So I divided by 2 and I got x equals 4. by division property. Is that what I was trying to prove? It is. Okay. So what's the big difference with geometric and algebraic proof? Another one. Okay. Number two. Two says that angle POG and angle GOT are a linear pair. Dawn, what linear pairs are? Yeah, 28. Well, that's a result of it, but they look like a what? It's in the name. Linear pair, the pair of angles that make a line. So, and they end up adding up to 180, right? But for a linear pair, let's go ahead and draw a little picture off to the right here. Usually you see it like this, kind of. Two angles together that are adjacent, they make a straight line. So POG and then GOT make a linear pair. Now the last problem we did was congruence. This one, look at those two angles. One's acute and one's obtuse. They're not the same, so I'm not going to set them equal. Someone already said this, but since they're not equal, what are they if they add up to a straight line? How many degrees is a straight line? 180. What's the math word that means that two angles add up to 180? Starts with an S. Supplementary, right? That's what's up, right? So here's the deal. We're going to start the same way as last time. Write the statement given. So what am I going to write first? Angle POG and angle GOT are what? Linear pair. Good. I would write kind of small because you're gonna have to fit some stuff in here. What's my first reason? Given. Okay. Now, before we start using numbers, we got to think, what does it mean to be a linear pair? We kind of just said it, but that means the two angles are what? What was that word? Supplementary. Y'all agree? They make a straight line. They're a linear pair. They're supplementary. So let's go ahead and write that as our second step. Angle POG, angle GOT are supplementary. And our reason will be, that's the definition of, and what was our first step? These things are what? Linear pair. So the reason they're supplementary, that's the definition of a linear pair. Okay. Now, let's talk about some numbers. If they're supplementary, that means their measurements add up to what? 180, right? So let's go ahead and write that. That means the measurement of angle POG plus the measurement of GOT equals 180. Okay, I went from saying they're supplementary to writing an equation equals 180. That would be a definition of what? What do you think? What do y'all think? Definition of what? I want you to see a pattern. Do you see how this was right there? So what should be right here? Supplementary, right? You're kind of defining each new word you're using. So because we said they were supplementary, now they add up to 180. That's the definition of supplementary. Now, kind of like earlier, we have these measurements. Don't we know these measurements up here at the top? So now what's that math word where I plug stuff in? Like when substitution, okay? So again, we set up a generic equation. Now we're going to plug stuff in. So instead of measure of angle POG, I'm going to put 2x plus 5 plus, instead of measure angle GOT, I'm going to put 3x. And that still equals 180 degrees. And all I did was plug stuff in. So that's going to be called what? Substitution. Plugging stuff in is substitution. Solve this algebraic. We got 2x. I'm talking about the same side. Do I combine or get rid of it? Combine. Same side, combine. Okay, let's do that. 2x and 3x combine to make 5x. Bring down plus 5 equals 180. Make sure you write small because you're going to need some room at the bottom. Oh my gosh. Now, I added them together. Is that addition property or is that combining like terms? What do you think? Combining like terms because it's on one side, not both sides. Okay, so combining like terms was my reason. And now we have 2 steps left. Now, obviously, I need to get rid of 5. Should I get rid of the 5 in front of x or after the x? Do you know? What does that mean? That means no? Sorry, after the x, to the right. Because it's the loner, it's the constant by itself. It's a positive 5, so what am I going to do? Minus 5, minus 5. Again, write small, please. You need more room, believe me. 5x equals what? 75 by subtraction property. Write small. That's all I can keep saying. Okay, how do I get rid of that 5? Divide, write small. $175 divided by 5. 35. By division property. Real quick though, is that what we're looking for? We're looking for the measure of angle GOT. Does everyone see that right here? Right here? Okay, so the measure of angle GOT is 105. That's not what we got. So why did we do all this? Well, last couple steps, you got to plug it back in. So measure of angle GOT, let's write that down. Measure of angle GOT equals, now GOT is 3x. I'm going to put 3, but what do I put in for x? Right here, yeah, x equals 35, so you're going to put it right down there. And I'm going to call that substitution. Didn't I just replace x with the 35, right? Substitution. Last step. What is 3 times 35? Anybody? 3 times 35. 105. Is that what we're looking for? Yeah. So that worked out. Measure of angle GOT equals 105. Now, this last step, when you just multiply something like that, that's not combining like terms, you're multiplying. So we call that just simplifying. Simplify. You only multiplied two numbers on one side, not both sides. So you can't say multiplication property, you're just simplifying, okay? That is an example of geometric proofs. So real quick, we're going to hold off on that third example on the back. This is good for now. Tomorrow we'll do an assignment on this, but if you didn't finish yesterday's assignment, then you'll have some time tomorrow too. We are going over your tests from last week, and we're going to see where your grades are. We're going to have a plan, all right?